I have a few examples here. I have two examples here. No, even more than that. Question number 20. Look what it says. It says, prove that the following set is a subspace. Look at this. It's the collection of all three-dimensional vectors. So it's a vectors with component x1, x2, and x3. It's a vector with components x1, x2, and x3, which are subject to the following condition. This is a typical question where our previous results, our previous slides are very helpful. We can argue this question. We can argue that this S is a subspace by simply referencing two lemmas. One of them is the orthogonal complement subspace lemma 2 slides ago, and the second one is the intersection of subspaces lemma. Look at this. I can say this. I can alternatively write the same set as follows. It will be the collection of all vectors x from R3 subject to the following condition. So I just took this left-hand side and equated it to 0, and then intersection with another set, x from R3 subject to the following condition. I just took this piece. You can't argue that, you can't deny this is true. If you have a vector with components x1, x2, and x3, which are subject to the condition that this number and this number equals 0, you can split these two individually into the collection of vectors with such that this condition is satisfied. Intersection, which is the synonym for the preposition and, with a condition like this. But the set of this type and the set of this type, they are simply my orthogonal complement subspaces. They simply, if I use my notation from the 2 slides ago, these are simply the S sub R with respect to the vector A like so, and with respect to the vector A like so. And now I finish my argument by saying this set individually is a subspace because of the orthogonal complement lemma from 2 slides ago. This set is a subspace because of the orthogonal complement lemma from 2 slides ago, and the intersection is a subspace because of the intersection of subspaces lemma from the previous slide. That's why the whole S is a subspace, as simple as this. By the intersection of intersection lemma and orthogonal complement lemma, and the question is done. Another question where a similar method will help you is the question 26. In fact, lots of questions in the yellow book can be argued in the same fashion. Lots of them can be reduced to the intersection lemma and the orthogonal complement lemma. And if you can do that, that means that you mastered this. I mean, if you can see that, and if you can do that, even though probably your tutor won't be doing that, in your tutorial probably your tutor will follow the subspace theorem directly applied, but if you can do it via this reference to these two lemmas, first you will see the huge difference because that's a lot shorter solution, and secondly, if you can do that, you can, my congratulations, it means that you just really reach a good level of understanding over subspaces, especially this type of subspaces.